A metal post is repeatedly hit in order to drive it into the ground. Given that on the first hit, the post is driven 100 millimeter into the ground. On the second hit, the post is driven an additional 98 millimeter into the ground. And on the third hit, the post is driven an additional 96 millimeter into the ground. The additional distances the post travels on each subsequent hit form an arithmetic sequence. Show that the post is driven an additional 62 millimeter into the ground with the 20th hit. So here it's an arithmetic sequences. The first term is given as 100, second term is 98, third term is 96, etc. up to we need to prove that the 20th term is 62. So here we have the first term as 100. Common difference D is second term minus first term. Second term is 98 minus the first term is 100, which is minus 2. And number of terms is given as 20. Nth term formula, we know it is A plus N minus 1 into D. So here A is 100 plus N is 20. 20 minus 1 is 19 into D is minus 2. So this is 100. 19 into minus 2 is minus 38. 100 minus 38 is 62. So that is what we had to prove in the first case, 62 millimeter. Now, this is the A part here. Now to find the B part, find the total distance that the post has been driven into the ground after 20 hits. That means we need to add all these 20 terms. That's what sum of 20 terms. And we know the formula for sum of 20 terms or sum of n terms. Sum of n terms, the formula is n by 2 into 2a plus n minus 1 into d. So n is 20. 20 divided by 2 will be 10 into 2 into a is 100 here. 2 into 100 is 200 plus n is 20. 20 minus 1 is 19 into minus 2. So this will be 10 into 200. 19 minus into minus 2 is minus 38. 200 minus 38, that is 162. So 10 into 162, that is 1620 millimeter. That will be the total number of distances after 20 hits. Now moving on to the third part. This was the B part here. This is the B part. Now for the C part, given that for each subsequent hit after the 20th hit, so till 20th hit, it was an arithmetic sequence. After the 20th hit, the additional distances the post travels form a geometric sequence with common ratio r. On the 22nd hit, the post is driven an additional 60 millimeter into the ground. Find the value of r, giving your answer to 3 decimal places. So here this is a geometric sequence, and 20th term, after 20th term onwards, from 20th term onwards, this forms a geometric sequence. So 20th term, we know it is 62 millimeter. We already got here in A part, the 20th term is 62. Now it's said that the common ratio is R. Now, we know the first term is A for a geometric sequence. Second term is AR, A into R. The third term of a geometric sequence is AR square. So 62 is the first term, A, and the second term, that is, this is the 20th term. 21st term will be 62 into the common ratio. 22nd term, it's already mentioned in the question that it is 60 millimeter. On the 22nd hit, the post is driven an additional 60 millimeter into the ground. So this 22nd hit is the third term. 20th term was 62. 21st term will be, it is A multiplied by R, second term. So A is 62. R is what we need to find out. So for the time being, let's take it as 62R. And the third term, that is 22nd term, is mentioned as 60. And we know it's the third term in the geometric sequence. If it is the third term in the geometric sequence, it is AR square. Now, AR square is equals to 60 and A we know it is 62. That is the first term of this geometric sequence. 62 R square is equals to 60. Therefore, R square will be 60 divided by 62. R will be square root of 60 divided by 62. Let's put that value in calculator. Square root of 60 divided by 62, which will give us 0.9833738, etc. This will be the R value. And now it's given that find the value of R, giving your answer to 3 decimal places. So if you are rounding it to 3 decimal places, this will be 0.98. Check the fourth one. It's more than 5. So add 1 to it. 984. 0.984 will be the value for R here. Now moving on to the last part, D. So to find out D, after a total of n hits, the post will have been driven more than 3 meter into the ground. Find, showing all steps in your working, the smallest possible value of n. So here, 3 meter is what they have said. 3 meter means, and we know everything is given in millimeter here, convert 3 meter into millimeter. 3 meter is 300 centimeter. 300 centimeter is 3000 millimeter. Now, for the first 20 hits, it was in an arithmetic sequence, and we already got in first 20 hits, this already reached 1620 millimeter. Now, after 20th hit, it starts geometric sequence, that is 62, 62R, 62R square, that is 60. Now, we need to find out the sum of n terms for this particular geometric sequence. Total it was 3000. For the first 20 hits, it's already 1620 millimeter deep. Subtract from 3000, 1620. So 3000 minus 1620 will give us 1380. So n is what we need to find out. A is 62 and sum of n terms for this geometric sequence should be 1380, and R we already got the value as 0.938738. It goes on like that. Now let's just substitute in this formula for nth term of a geometric sequence, and we know nth term of a geometric sequence is A into 1 minus R to the power of n divided by 1 minus R if R is less than 1. In this case, R is less than 1. So sum of n terms, we know it is 1380. A is 62 into 1 minus R is 0.983738 to the power of n divided by 1 minus 0.983738. Now, just normal algebra. Take the 62 to the left hand side. So multiplication becomes division. 1380 divided by 62 is equal to 1 minus 0.983738. Or you can just simply take 0.984. It's okay. You will get the same answer. Divide by 1 minus. What will that be? 1 minus 0.983738. 0.016262. I'm just going to cross multiply with this and divide by 62 to simplify it further. So multiply that with 1380 and divide by 62. We'll get 0.36196 is equal to 1 minus 0.98 0.3738 to the power of n. Take this to the power of n to the left hand side, it becomes positive. So 0.983738 to the power of n is equals to 1 minus 0.36196. That will give us 0.984 to the power of n is equals to 0.638. So we can use logarithm here. So put log on both the sides. So we will get log 0.984 to the power of n is equal to log 0.638. Log a to the power of n is n log 0.984 is equals to log 0.638. So n will be log 0.638 divided by log 0.984. Let's put that log 0.638 divided by log 0.984, which will give us 27.8. Therefore, we need to always round it up, since it should be fine showing all steps in your working the smallest possible value of n. The smallest possible value of n in this case will be 28. Now, first 20 terms from the arithmetic sequence, and then the remaining 28 terms from the geometric sequence. So 20 plus 28, 48th term will exceed 3 meter. 48th term will exceed 3 meter or 3000 millimeter. So we started with the nth term formula for A part, then sum of n terms for the B part, and we framed the geometric sequence and we found out R common ratio, and then using that framed geometric sequence here, we used sum of n terms to get the value for n, that is number of terms. So altogether 20 terms from the arithmetic sequence and 28 terms from the geometric sequence will add up to give you 48 terms. So once after 48 hits, then the post will be reaching 3000 millimeter or 3 meter. So I hope you have understood this. Thank you for watching.